Hi everybody, welcome back to Database Management System presentation series. This is Satyadev from VNR VJEC CSC department. So in the last presentation, which was the first presentation, we have seen the definitions of database management system, various other aspects like what is data, what is database, what is management system. All these things we have seen, and also we have seen the very first data management system, which is file-based management system, how it works and what are the issues with that, and then we talked about how DBMS, database management system, circumvent those issues and provide better results. So that's what we have seen in the last presentation. In this presentation, we are going to talk about history of DBMS, and also we are going to see prominent personalities that contributed to the development of DBMS. So it starts from the basic file processing system (FPS) till DBMS and the latest and greatest, NoSQL databases, cloud database, and all that stuff. Again, this is in the perspective of history, so it's not going to go much deep into everything, but that's pretty much what we are going to discuss today. So yeah, let's go to the first slide. In 1950s, the first data management system using files has been invented. So flat file systems, basically we discussed about it, like text files and raw binary files. So that's the system that started in 1950s, back in 19, so way back. Basically at that time, computers were completely different compared to what we are seeing now. They were like micros, mini computers. Sorry, there were no micros. There are mini computers, and which were using like mainframes, which were using like file taped magnetic tapes, and disc readers, and just like gramophone record reader. So they used to use them. So the system was entirely different at the time. The hardware, the computer hardware was different. The data management system was different. But again, they used file-based system. They created to in order to store the data and do the CRUD operations. Basically, that's pretty much what we do in database management system, right? CRUD, create, retrieve, update, and delete. So any data which is useful, that's what we do in 1950. Then again, back in 1966, the first widely used system was developed by IBM, which is like hierarchical model. We will discuss hierarchical model in the next presentation, how the data is organized in a hierarchical way. This is done as part of NASA's Apollo program. So this is more like a database system created for the NASA aerospace organization of USA, United States of America. So that was in 1966. 1969, there was another model called data organization model called network model is created. So DBTG, group like formalizes the network model, and it stores data in a network organization, like not like a hierarchical but network. So that's about like back in 60s and 50s, 60s and early 70s. Now in 1970, there was a revolutionary paper written by Edward F. Codd from IBM, which talks about relational data models. The paper titled as a relational model of data for large shared data banks. That's pretty much the title of the paper. He actually provided insights into how data can be stored using a relational model. He pioneered this model. So Codd is, we could say, the father of RDBMS. We could call him as E.F. Codd as the father of RDBMS. So his name is going to be repeated multiple times as we go through this series. So that's back in 1970, he pioneered the idea. Then 73, there was this system by University of California, Berkeley University. They created this Ingress project where they wanted to utilize this RDBMS kind of thing, and they created Ingress, basically, which is a conceptual thing for the latter RDBMS product like Postgres, SQL, and Sybase, and Informix, and all that stuff, right? So that's 1973. In 1974, again IBM provided a prototype database system called R System R, and they pioneered this language called SQL. We will talk about SQL little later, but SQL language which is used for database management. Now 1979, Oracle got shipped. The first version of Oracle got shipped. So that means like Oracle is not very recent one. It's been there for a long time, right? That's pretty much what it is. Then in 1986, SQL has been standardized. So that's pretty much the until 80s. One more thing I would like to add in, which is not there in this presentation. When this presentation is that back in the 80s, there are other software tools like database, DBase 3.2, DBase 3 Plus, Foxbase, Clipper, by companies like Ashton Tate. So they were in the market. They were widely used by many commercial people. So I would say like around mid 80s to early 90s, market was ruled by applications like Foxbase, Clipper, Fox Plus, and all those database-based applications. But one thing is that they are all monolithic applications. So what is monolithic I will discuss later. But they are one application which does everything, that kind of stuff. That's what monolithic is. So that's about changes in 1986. Then 1990 has seen the birth of data warehousing. So basically the difference between database management system and data warehousing is that database management system is used for the live data. Data comes in, you update the data, you remove the data, you add data. There's a lot of transactions going on, a lot of juggling going on with the data in database management system. Whereas data warehousing is not like transactional, it's more like a analytic purpose. So you store the data in a place, you back up the data, and you apply analytics on that data. So again, that data is huge. The live data is always like small, right? So compared to the past historical data. For example, you have been storing data for the last 10 years, but this year data is only one you are more interested in, right? That's stored in DBMS. Whereas the last 9 years data or 10 years data, whatever it is, stored in data warehousing. That's a past data. The reason we store in data warehousing concept is for OLAP application, online analytic platform. OLAP means online analytic platforms. So to perform some analysis. So basically they are not for the OLTP, online transaction processing. So they are for analytics process. Then 2006, Google invented Big Table, which is like relational, it's scalable, and also sparking, all these things, and which actually started the NoSQL movement. So basically NoSQL means not only SQL. It's not like there is no SQL. It is like No means not only SQL, which adds more stuff, right? That's pretty much what it means. So 2006 has seen the birth of NoSQL, and 2008 NoSQL databases like Cassandra, MongoDB, Redis, all those things came into market, which were like very useful for different kinds of purposes. Especially as the internet grow, the storing of data in the cloud, is very important. For example, you have a chat application, right? So you are a Twitter applications. So you can't store the Twitter data in a database management system because DBMS or RDBMS, basically relational database management systems, are a bit slow. But you store in a NoSQL database, which is really fast because of reasons. Some reasons it is really fast, which we will discuss. When we discuss NoSQL. But as of now, a deep discussion on NoSQL is outside the scope of our discussion. So then NewSQL comes in. Google Spanner has come in 2012. Today, databases are actually not, yes, they are centralized, not only centralized, but are also distributed. So initially they were like everywhere. Then they got centralized using RDBMS and other concepts. Now they are again become distributed. But this distribution is different from previous ones. So I think again the discussion of that is beyond the scope of this topic. But now again we are going for the distributed databases, and also fast access to the databases and all that stuff, right? So mostly it is all cloud driven, like Aurora, Snowflake, Cockroach DB, all those things, like all these things like are actually cloud-based databases, which we use to store our heterogeneous data. Basically, until 2006, we were until 90s and early 2000, we were talking about homogeneous data, mostly relational. So I would say around 70s, late 70s to early 2000s. It's all RDBMS is ruled by RDBMS, and mid to 2000 2006, 2000 yeah, onwards, 2005 onwards, like it's more of like going towards NoSQL. Now it is in the cloud, so that's how we are progressing, right? So yeah, that's again nowadays it's a database management system actually uses is a mix of like local centralized databases like RDBMS and cloud and um, and NoSQL databases, which is like distributed. All those things are kind of mixed and matched. So that's pretty much what the history of database management system. Now let's see some of the important names in the pioneers, or names in the work, the DBMS work. Like who have contributed a lot to the development of databases. Back in 1950 and 60s, Charles Backman, so he developed Ingress, like Ingress Integrated Data Store, IDS, which is like the first database management system. IDS is the first data management system which is developed in IBM, which uses the network model. So again, it was awarded in 1973 and all that stuff. So that's pretty much it. Then 1960, Grace Hopper, actually she was a COBOL programmer. She helped popularize structured management concepts, and try to apply the database concepts using the COBOL. COBOL is basically a computer programming language, which was very popular in 1960 till late 80s. I believe the full form of COBOL is Common Business Oriented Language. Common Business Oriented Language, COBOL. So, which is actually mainly towards the file management systems. COBOL has a lot of features related to managing data using files, update, delete, all those things are embedded into the language itself. So, it was very popular at the time. So, Grace Hopper helped, COBOL to get popularized using that kind of database concept. So, her name has to be remembered. Again, Edgar F. Card, I think I would say, like I said earlier, he would say he's the father of modern RDBMS. Like, so he proposed relational data models back in the 70s, and those concepts have been taken by SQL Server, MySQL, Postgres, Oracle, anything like Foxbase, Clipper. All these things have taken those concepts and created RDBMS. So basically, DBMS is a general term, database management system. RDBMS is a specific thing which we will discuss in the next presentation, relational database management system. So which is a type of DBMS. RDBMS is a type of DBMS. So then Donald D. Chamberlain, so she created like SQL, structured query language, at IBM. So which we'll see what is SQL in the next presentation. Raymond F. Boise. So this is another important name like Card. He actually he wrote a paper to make the database system better. So he introduced the concept of normalization, first normal form, second normal form, third normal, BCNF, Boise code normal form. All these things have been coined by him, which are like very, very important for making the databases more rational and simple and easy to use and faster to perform. Then 1970s, Peterson introduced entity relationship model, which we will discuss more in detail in the next presentation and so on. But this is a model which is like a conceptual model. This is not actually a model where you store the data like RDBMS. It is like before designing a database system use intelligence model to figure out how our system should be. That's where Peterson has pioneered. Then James Gray in 1970s again, transaction management, concurrency control, recovery, ACID principles. So all these things have been coined, pioneered by James Gray, which is also another important name. So I would say as of now, still most important names like which are still in use, I would say like Cod, Boise, Peter and James. So these are the guys whose work is still being used in many of the applications. So that's about it. So again, 1970s to 80s, Patricia Schellinger. So is she actually optimized our project and introduced cost-based queries like okay, you can, in order to achieve certain task, you can do it multiple ways. Which one is more time critical, or which can perform better way? So she created theory for that and provide that. Michael is the one who developed stone brackets. So developed Ingress, which is actually, as I told you earlier, which is like parent of PostgreSQL, which we are using nowadays. And again, Ronald Fag in 1980s. Again, he contributed more to the normalization, multi-valued dependencies, database design. All these things we will learn later presentations. So, Jim Gray, 1990s, advanced large-scale database reliability, fault tolerance, distributed transaction processing. So, 19 onwards, Jim Gray's contributions are very useful because he has pioneered the idea of how when the data is distributed, that means you don't have the entire data at one place. Region 1, for example, you are storing sales data. You don't want to store sales data in all the regions of India at one place. You store region specific one. You need to get region 1 data. You just connect to the server and get the data like that. The databases are same. The structure of the databases is same, but the data inside is different, specific to the region. So that's what he pioneered. The concepts are the ideas for that. He pioneered that. Jeff Dean and Sanjay, they pioneered like Hadoop kind of stuff like MapReduce, big tables and all that stuff. So, and also influenced modern NoSQL cloud-based databases. Now, recently, in 2000, Eric Brewer, as the databases are now distributed, he pioneered a theorem called CAP theorem, which is like consistency, availability, and partition tolerance. So, which is applicable only to distributed databases and NoSQL systems, not to the RDBMS. So, RDBMS uses ACID principles. Distributed systems use CAP theorem. Again, two are different aspects, but that's how we can relate. CAP theorem. So, again, discussion of CAP theorem is beyond the scope of this topic. So, I'm going to differ. So that's pretty much about the pioneers and their work. So I think that's about the history and pioneers of the DBMS. Thank you very much.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.